good morning, good afternoon, or good evening, whenever you're watching this video. On today's lesson, we're going to try and build a very similar model to what we did on the video before. Very similar exercise. We're going to try and predict uh, some kind of plant from the iris dataset. Okay, but what we're going to do different this time is that we're going to actually split the data between training and testing. In the previous video, what I tried to do mostly was that you could understand like the full process of machine learning, okay, of building like a minimal model, which may not be the best model, but it's at least a model you can use to predict, and maybe you can go and try yourself building a similar model. But the thing in real life is that you don't use the 100% of the data you have for training the model. Okay, and this happens for various reasons. The first one is that, or the most important one, is overfitting. Okay, and overfitting is when the model behaves so well for the data that it fits perfectly. Okay, it fits like 100% of the data, and it's gonna test very good accuracy. Okay, but the thing is that it's so well trained for the training data that it's going to then fail in real life. Okay, I always put the example like um, maybe a student has to take a test, an exam with a teacher, and what he does is that he goes back in history with some other students and try and pick up some previous exams from this teacher, and he's going to then learn some patterns from the exams instead of actually learning the instead of actually studying for the exam, studying the lessons. He's just going to learn some patterns in the exam. Okay, like for example, let's say he realizes like from comparing different exams that the teacher always uses the option C in the exam in the first question. Okay, so he doesn't even care about what the question is, what it is asking about. He just knows, he recognizes that always the teacher uses option C on the first one. Okay, so when he's going to take the test, he's just going to mark C on the exam. Okay, but he's not actually learning anything from the matter, from the subject. He's just learning what option is correct. He's just training for him for taking an exam, for getting a good result in the exam, but he's not actually learning the subject. The same is going on with the training, with the overfitting, because as it has so much information, the model, then it will learn the patterns in this specific training. Okay, so what will happen in real life is that this model maybe it's overfitted, and then you're going to actually fail in real life because you're not going to have like a very good knowledge or understanding. This is the same that's going to happen with the model. So let's see how we do this in Kaggle using our previous notebook, which we'll link in the description so you can use it here. Thank you. Okay, so bear with me for a second, because what we're going to do first is we're going to try and copy this notebook. What we do here is that we come to edit, and we hit here on the number at the top right, and then you go to the viewer where it opens a new screen, and then you finally um, copy and edit the notebook. As you see, this new notebook um, is called fork. Getting started. I'm going to just add v2. And the first thing we're going to try to do is to start the kernel, because this will take a while, or the instance or the virtual machine underneath to actually start. Okay, so what we're going to do is that we're going to add some things here. Okay, so this is the same notebook from the previous lesson. And now here we're just going to add another import. Okay. Um, we're going to import train test split. Okay, and what we're going to do then is that right after this code, we do this train test split. And what we're going to do is that we're going to use our data and our target, and we're going to split them. Okay, so we have all the features from the, let's see, we have all the features from the flower, from the plant, right? And then we also have the targets. Okay, so we have target 0, 1, and 2, and we have, remember, 50 of each one of the flowers. We have 50 of Setosa, 50 versicolor, and 50 virginica. And what we're going to do is that we're going to, from all those 150 150 rows of different kind of plants, we're going to split that. We're going to take 30% of the data, and then we're going to move it apart. Okay, this is data that is not going to be used during the training, but then we're going to actually compare it. All right. So what we do here is that we use the train test split function. Okay, it's giving the data columns from the dataset, the target column, and then here we have a parameter called test size. Test size will indicate the percent data that we're going to use. We can use, for example, as little as maybe 15%, for example. It is recommended, depending on the size of your data, to use between 15 to maybe 30% tops. Okay, and very important here is the random state. Okay, it's not that important, this number, but actually to use it. Okay, because this random state, this guarantees that you're going to, no matter what happens, you're going to split the data in the same form. Okay, so this guarantees that the model will use the same data once and again when it's going to train. So it's going to give you the same results. A very important thing to keep in mind in data science, as I always say, is reproducibility, that you can test a specific pattern or a specific exercise no matter how many times you try it, day, night, in your computer, in the cloud computing, it should give you the same result. Okay, and you guarantee that with using random state and just putting a number here. I used 1, 2, 3, but you can use whatever number you have in mind. Just keep the same number for your exercises. Okay. Here one, I just wanted to circle back on the train test split function and the random state parameter that gives you reproducibility. What this means is that when you put a specific number, in this case, for example, 1, 2, 3, is that with this exact data set and this exact number 1, 2, 3, no matter how many times you execute this function, it is gonna split the, in this case, let's say 70% for training and 30% for data. What it's going to do is going to split them in the exact same data, the exact same rows, not only the number, the quantity of rows, but the size, but also the exact rows, okay, the exact content is going to be split in the same way, no matter how many times you run this, no matter which computer it is, if it's cloud, if it's Linux, if it's Windows, if it has the random state 1, 2, 3, and this exact same data set is going to do the same split always. And what this is going to do is that you're going to feed your model with the exact same data set, with the exact same rows, okay? And then you're going to do the test and the validation against the exact same rows. So this is very important that we do this with a number. As I said, it doesn't matter which number it is, as long as it is the same number, which will guarantee that you run this over and over, and then you compare the performance of your model in many, many runs and many comparisons. So let's get back to the video. Okay. So yeah, let's execute here. And what this is going to do is going to create 4 different variables. The first will be the data that will be used for training. This will be the input for the model and the data for testing. I'm going to keep this apart. And then we will have also the target split, also 70% for training and 30% for testing. Okay, so then what we're going to do, you see this just keeps the same, but what we're going to do is that we're going to use the data from training and also the target from training. And we have the random forest classifier already built, our model. And then what we're going to do is to check the predictions. Okay, so here, for example, I'm going to just test the data. Sorry here. Okay, so now what we're going to do is to see what's in here. These are the predictions. This is an array, sorry. So let's use the 5. So these are the first 5 ones that the model is predicting. It's predicting 1, 2, 1, 0, which will be 1 is versicolor, 2 is virginica. Okay, so these are the predictions. Now I want to compare um, with the actual with the actual. Now we want to compare with what actually was inside the model. Okay, so this will be okay. So this isn't a very good one actually. Oh, okay, I made a mistake here. It's actually not that bad. Okay, so what's happening here? Um, I use the data from testing, the data that I hold out from the model. Is data that the model hasn't seen at all before training. Okay, this data wasn't seen during training. And now what I'm going to do is that I'm going to use this data on scene and give it to the model, to the random forest classifier, so it can do its own predictions. Okay, and then these predictions are here. Okay, so these are the first predictions. I store them in the target pred variable, and I'm just showing here the first 5. All right, and remember, as I hold not only the data for training, but I also hold the labels for the predictions, and the labels were in the target test variable. Okay, so I had, as you can see here, it's 1 2 2 1 0. So it's very good one. We can see it's like 100% right now. We can maybe extend it a little bit to the first 10 and see like manually if it fits or not. So 1 2 2 um 1 0 to 1 0 0. Okay, this looks like 100% of accuracy until now, but we can maybe just be sure right now with another function, another method. Okay, this method is accuracy score, and what we're going to do is to let it do the predictions for us. So let me copy this. So what we're going to do is that we're going to build the accuracy. So we're going to compare the predicted, okay, our test. This is like our guide, the correct answers, right? And then the predictions. And then we're going to try and see how it went. So what was the accuracy here? For example. So this was a very good one, 95%. Let's see it. Okay, so we can see here, it's gonna be a huge print, but let's see where. Okay, you can see here that it almost all of them, it was, except maybe for this one, that I didn't maybe actually do a correct guess. Okay, so let's increase, for example, the splitting. Let's give it more test size. And it's a very good question, like what would you think would happen? Uh, would you think that it's going to increase the accuracy, or it's going to actually get worse? Okay, so maybe you can pause the video right now and take a look at the exercise, what we have done, and what you think it's going to happen. Okay, we're giving the model less data for training. We're giving it just 70%. Okay, and we are holding the 30% remaining for testing purposes. Okay, let's see what happens. I'm going to do the split. I'll just skip this and then once again train the model with less data. So let's see what happens. We're going to run the predictions and let's see how it works here. Okay, the model seems okay. Now it's here. This one is wrong. It's correct. Okay, now we have a first one bad guess from the model in the first 10. So let's see what happens here. So as you see, the model decreased a little bit on the accuracy. This was only 93% instead of 95, but it's still a good model. This is still a good accuracy. Okay, so this, as you saw, this decreased the model accuracy, but it's okay. It's okay because we shouldn't be like testing or maybe optimizing for the training data. You should be optimizing for the real life data in your model. So don't be hard on you if your model gives you like 75 or 80%. in your prediction data. Okay, so this was the exercise. I hope you got a great understanding of um, train and test splitting. Also on the accuracy measure, what it does, and how you actually divide the data into the data and the target labels you're actually trying to predict. Okay, that was it. So thank you very much for watching, for staying until the end. It's very important for me to create this content. So you can please give a like on this video and subscribe. So that's it. I hope you have enjoyed, and please comment any doubts you have. Bye bye.